Hello viewers, I'm Michelle Froese, Senior Editor of Windpower Engineering and Development magazine, and we are in Cleveland, Ohio. We have the Science Center at our back with the onshore turbine there, and we have Lake Erie to our left, the future home of the very first freshwater offshore wind farm in North America. Today we have Dr. Lorry Wagner joining us. Dr. Wagner is from the Lake Erie Energy Development Corporation, or LEEDco. He is an energy engineer and the president of LEEDco. And he's going to answer some questions for us today about what will be known as the Icebreaker Project. So thank you so much for taking the time out of your schedule.
Sure, good to be here.
That's great. So first, let's start off by asking you about the project, where the plans are at, and what we can expect from the Icebreaker Project.
Yeah, well, we've been engaged in the development of this project really since 2010. The vision started in 2004, but the whole idea was to build this demonstration project to prove that we can do that here in the Great Lakes. We're currently finishing up the design on the foundation. We're working on the permits, both federal and state, and we're working to sell the final portion of the electricity. We have 2/3 of it committed with a PPA, and then 1/3 of it is we're trying to fit that in to a number of different customers and get that finished. So that will take us, once we complete that, that'll take us to the construction phase, which should begin in 2018.
So tell us a little bit about the wind turbine. So their hub height, rotor diameter, capacity, what can we expect?
Yeah, for the wind turbines, we always decided from the beginning that we wanted a well-proven technology. So with all the uncertainties in the first project, we didn't want the turbine to be any issue at all. So we picked kind of a mainstream, smaller turbine. Well, it's not really small, but instead of the 8 megawatt monsters that are going up in Europe now, we have about a 3.5 megawatt turbine. Very well proven, and by the time we install it, there'll be about 1,600 of them deployed in the offshore environment and onshore. So the turbine itself has a rotor diameter of 126 meters, which is pretty large for a small turbine like that. And then hub height is 83 meters. And then the actual transition piece platform is about 11 meters above the water.
Okay. And you mentioned the foundations earlier.
Yeah.
I hear that they're going to be quite unique. Can you tell us a little bit about them?
Yeah, the foundations are known as a suction bucket.
Okay.
And basically they are a technology developed in the oil and gas industry where you take the upside down container, put it on the seabed, suck the water out, and then it pulls the foundation into the soil and captures the soil and makes that part of the foundation. So our design was developed by a company called Universal Foundation in Denmark. They put up a 3 megawatt turbine, same manufacturer that we're using, in 2002 to prove that this was a viable solution. So they have 14 years of data. They've also done some other installations in the North Sea. So it's really it's very innovative. It's no noise, there's no hammering, there's no seabed disturbance, and it's the lowest cost solution for the industry.
That's great. And so why Lake Erie? Why here? What advantages are there to freshwater?
Okay, well, if I could tell you that little story.
Absolutely.
About meeting Fred Olson in the Canary Islands.
Mm-hmm.
We sat down and we introduced each other, and I said, we're doing a project in Lake Erie. And he goes, you know, I just don't understand why anybody wants to do a project in the Atlantic. You go to the lakes because the waves are smaller. Instead of 100-foot waves, you have 20-foot waves. You have fresh water instead of salt water, corrosion. He keeps going on and on and on. Lake Erie is pretty uniformly shallow, has an average depth of 23 meters. Even the farthest out we would go over the horizon, you're still pretty close to ports. 20, 25 miles. It's got a great wind resource. Actually, our wind in Lake Erie is better than the wind in the Mid-Atlantic.
Really?
Yeah, the North Atlantic
Amazing.
is screaming.
Yeah.
But the Mid-Atlantic is decent, but we're better than that. So Lake Erie kind of has a lot of the qualities, and you know, you could say it's easier I mean, none of this that we're doing is easy.
Of course.
But let's just say the challenges are a little bit less in the lakes than in the Atlantic.
Interesting. Yeah. And whereabouts will the turbines be located? Will you be able to see them from shore, or?
Yeah. Well, if we stand here and look out, and it's 323 degrees on the compass. So from here, we would see the turbines lined up one behind the other.
Okay, interesting.
And with maybe a tiny spacing, and also at this point they would be about this big.
Wow.
So 8 to 10 miles out.
Yeah.
Really makes it a very small object. In fact, most people will think there's some sailboats out there.
Interesting. Wow.
Yeah.
And what about the equipment that's needed to get the construction going, the installation? What types of vessels are needed? Have you guys thought that far ahead in the process yet?
Yeah, one of our partners, Fred Olsen Wind Carrier, which is part of the group, is one of the leaders in the industry, and they have taken over the installation process for us. And the fundamental methodology, which has been used in Europe as well, is to get a crane barge, put jack-up legs on it to make a stable platform, and then get a crawler crane from land, put it on there, and then go out and do the erection of the foundation of the wind turbine. And then there's all kinds of other vessels and logistics. When you see the construction on any given day, you'll probably see about a dozen vessels out there, from safety vessels to guard vessels to crew transfer vessels, and then there'll be two main platforms. You'll have the crane platform and then a small jack-up barge which will hold the component, and then the crane will pick it off and then put it up.
When will installation, construction start, and when will it be complete?
Yeah, well, that's always
what are the goals?
Good question. Yeah, the goal right now is to start construction and finish at the end of 2018.
Okay.
We have a lot of things to do before then, but it's very doable, and it's just a matter of getting it right, which is really the most important thing. And then the schedule becomes what it's going to become. We don't have a deadline as such.
And who will benefit from the power then? Will it feed right into the grid here in Cleveland, or how will that work?
Well, one of the other pieces of the story that Fred also reminded me is that we have 2.8 gigawatts of unused substations along the lakefront, old coal plants. We have a 2-unit nuke plant that only collected one, that was only built one. So we have another substation there that could be utilized. So we actually plugged into the Cleveland Public Power Lake Road substation, which is an old abandoned 40 megawatt coal plant. That plant was shut in the 70s, but the infrastructure and the substation is there, so we were able to plug right in. And the future vision is wherever we go in the lakes, we will already have an existing substation to plug into. In a way, we're sort of behind the meter on this project, which for the viewers that understand, how we are selling the electricity, we get a real economic benefit by going into the city grid directly and not having to go out onto the PJM regional transmission grid.
Thank you. Thanks so much for your time, Dr. Wagner. If our viewers want to learn more about the Icebreaker Project or about LEEDco, where can they go?
Well, certainly they can go to our website at leedco.org, and there's a list of everybody on there, and I'm happy to talk to anybody. Send me an email, and I will get back to you.
Wonderful. Thanks again for your time, and thanks for your attention, viewers. This is Michelle Froese for Windpower Engineering and Development.